Hello, welcome to another devlog for my 2D space game. So there's a bit of a dilemma when it comes to implementing mineable shapes. We currently have this worth system, and there's a hidden cost multiplier that's kind of used as the purity. If this is 1, then the mass of the resources is equal to the mass of the shape. But then let's imagine we can now drain these resources, like the worth. If you drain it all, then this shape will be free. Like it's gonna be worthless. And then if we put this in the zone, we're gonna be able to make it as large as we want, I think. It's kind of weird. It depends on how we implement the cost. So a shape should always have at least some worth so that we can't make it free. That's like maybe rule number 1 for making mining happen. And then rule number 2 is we gotta preserve mass. So let's say in addition to the worth here, we have a point here. Imagine this is like a huge boulder and like a mining rig would fit like here. And we have a point here that's mineable and maybe it has like 10 iron. If we activate this mining rig and it drains it into a storage, then that 10 iron is gonna add to the mass of that storage, equal to 10 iron. But then let's imagine before we mine it, these 10 iron that live in the shape, before we mine them, they should already weigh 10 iron. But how do we apply that mass? We could just apply it to the shape itself. So then we would just make sure that the worth of the shape plus the sum of all the mineable resources, that the mass of that does not exceed the mass of the shape itself. And then when we mine this 10 iron there, then that mass will be subtracted from the shape here and it would be added to the storage. But I'm also thinking about these new joints we have. So we have this joint right there that's indicated by that those circles. We had some ideas to make the joint cost something, because right now the joints are free, and then that the weight of those resources would be added to this ghost shape that doesn't have any collisions. And I feel like that functionality, a ghost shape, is pretty similar to a mineable resource in the planet. A non-collidable shape with a collection. We won't be able to mine from the joints. It's either delete or nothing, but then the joints we will be able to mine from. So they're a bit different, but they share functionality. So let's keep that in mind when we design the mineable points. But yeah, I feel a bit overwhelmed. So let's try to do one thing at a time and start with the mineable points. And to do that, we should add some worth to the planet as well. So because currently it's free. Ooh, these triangles are free, I just realized. What if we turn off God mode? We have that in here now. And now if we manage to get this triangle into the zone, we can make it as large as we want. So not even these triangles can be free. Right. Probably just make a check for that, so we raise an error if any shape is free. Another option is putting actual shapes inside the shape. But then we would be overlapping shapes, and I've kind of decided to not allow that, because overlapping creates a bunch of issues I don't want to solve. But perhaps this could be an exception, because then like the points you're mining from would be very similar to these boulders. Like just imagine this boulder is buried in this shape. Then the mass and stuff would just be sorted automatically because it's already fixed here. And then when we drain it completely, we just delete it. We could even be resizing them. Like if you could see this shape inside there, like some would be bigger than others, then as you're draining it, it's shrinking. It'd be pretty cool. And then like I don't want the mineable parts to be visible unless you have a scanner. So imagine you scan here and then like you get a shape here, pretty small, and then a big one over there, and then a huge one down there. That's pretty interesting. But then these shapes, they would be a bit special. Well, they would be combined with this body to begin with, and we would have to draw them after we draw the planet. So we would have to create a new batch layer. But then what happens if you have a zone encapsulating the whole planet and you delete the planet? Or like a more reasonable example is if we have an asteroid that have a few mineable shapes inside it and you delete that asteroid. What happens with the mineable shapes? Do they become normal shapes and just float around there and fall to gravity, etc.? Or should they be included in the calculations when you delete the planet? You need to fit all the resources of the planet into the storage. But what if we also make sure we have to fit all the mineable shapes as well? So then the mineable shapes are deleted with the main shape. But then if we're able to mine from shapes, like I don't think we should allow the player to create mineable shapes. So that means a mineable shape is always a custom class or whatever, custom module, and we can't create that module ourselves. And we could optionally allow users to delete only the mineable shape. Like they should be selectable, just like this would make sense. But I'm not sure. I'm afraid it gets too complicated. It would be pretty cool though, that they're not just dots, like all the same size. Trying to get this working, we now have some boulders spawning inside the planet, and they're much larger. Like they're a bit too large though. Maybe something like this. Yeah, seems better. And these boulders are sensors. So I'm not sure about the distinction I'll make, but they're the same as these boulders on the surface, except they are sensors and they're attached to the planet body, whereas these boulders on the surface have their own body. So I want to implement some special functionality for sensor shapes. To begin with, they should be drawn separately in their own batch, because right now I can only see them when I highlight the planet, and they just happen to be drawn after the planet. But otherwise, they're the same color there. Although I guess, do they even need to be their own batch? Because I'll always create the main shape before. No, they need to, because this logic should work for when we create like these pivot joints. This shape in the middle there is also gonna be a sensor shape. Right now it's just faked. It's only being drawn. It's not an actual shape. But this circle in there should be the same as these boulders inside the planet that we're going to be able to mine. But we're not going to be able to mine the pivot joints. But the key functionality is that they can have a mass and store things. So when we create the pivot, a more expensive pivot is going to be heavier and hold more resources. Same with the mineable boulders. The bigger they are, the more resources they hold. Same as with these boulders. So far, so good. Introducing these sensor shapes. Each normal shape can have a set of sensor children, and then those children can have a sensor parent. And we set those down here when we create a sensor shape. We just assign it to the touching shape for now. It's not going to work for the joints though, so we need a better way for choosing which shape a sensor shape should belong to. Perhaps we'll just take the closest shape within the same body. That makes more sense. When we change a shape's body, we also change all its sensor shape children's bodies to the same one. Made it so we can't select sensor shapes, and I think those are the tests are passing, which is nice. Don't have too many tests for what we're doing now though, but good to see that the rest is working. So yeah, and I also got a custom style for the boulders, so we can see them always a bit darker. And so now if I turn on God mode and we move the planet, you can see all the sensor shapes follow nicely, but resizing is not gonna work, I think. Well, let's try it. Ooh. Make it larger, right? Yeah, but it's when oh, that's funky. So when you make it too small, right, it loses its sensor parent because it's no longer touching. Like, that was a comment I made. But that's pretty cool. But then we just gotta make it so when we resize that those are selected with it. Alright, getting there, we now query for the closest shape. This might belong to different body though, for some reason. So let's do this. Let's put an assert there. Sanity check. So that works nicely, and nice. Then I put the max distance to 10,000. So if we make it too small, it should crash. Nice. Because pivots, for example, they're gonna be allowed to be outside of the shapes, but they're not gonna be able to be infinitely far. But I haven't implemented some distance limit there yet. But this number should have something to do with that, I think. When I made the resizing, I decided to only make it work for single shapes, because resizing multiple shapes at the same time seems pretty complicated. A lot of edge cases. So when you resize the shape now, you make it single, so it's disconnected from whatever shape it's connected to, and then you can re-weld it. So not ideal. And like, it would be cool if we could resize these together, but like that would mean something similar as to when we move shapes together. I got that sorted at least. But then if we make this larger, it's gonna have to move this shape, because right now it doesn't move any shapes when you resize. So we'd have to move this shape and make it larger. Once I figured that out, then we can easily apply the same logic to being able to resize planets with sensor shapes in them. So I think now, just to get the mining working, I'm just gonna disable resizing if it has sensor shapes. But before that, let's quickly get the deleting working. So I've changed the pre-delete check to also include any resources from their sensor shapes. And then if God mode isn't on, then it checks that there's room for all those resources before deleting. And then when we actually delete it, we just delete all the sensor children as well. Should probably do something like this as well. Just in case we only remove a sensor shape, we should remove it from its parents' children. And maybe reset this as well. Make sure that's optional. All right. You can just set it there as well. Cool. And make sure it works. Well, oh right, of course. If you are a sensor, we do that. Cool. And nope. Right. Now that we do this, we gotta wait. No. We just do this afterward. Delete and we have to copy it because it's gonna change during iteration. Nice. Let's just make sure this works. Should make a test for it, but let's prototype it first and then we can add tests and stuff. All right, that should show us the difference. Okay, right. The planet is worthless. And then we have 209 million scrap, 18 million silicon, 50 million titanium, iron, copper. Cool. Seems to be working well. Got a basic miner action in place. And I'm just printing the number of shapes it's touching. And I put a cooldown for 1 second on that. Turning on God mode, can create it there. We can see it takes a lot of power. Pretty cool. Like, smaller it is, the smaller the power. Same as everything. Then we let it fall there. We can see, oh, if we turn it on. So this is a bit confusing because now it looks like it's on, but I think I should say that it's enabled. Because to turn it on, you actually need to press the keybind, or you can just toggle that keybind here. So turning on and off should be enable or disable. But then, whatever, let's toggle on the miner. And then we can see it's printing one there. So it's touching one shape. Let's move it to touch two shapes there and it should print two. So using this, we have some options here actually. One option is that it can mine anything within its range, even if it's in the air. And I just thought about this today. Like, that could be really cool because then you could put a miner into orbit, into low orbit, and it could mine as it goes around the planet. But then if it's a very uneven planet, it's only going to get the things on the top of the mountains, or like at the highest altitudes, because we don't actually have mountains since they're all convex or concave. Not sure which one. But yeah, that would be really cool. So that could be a different action. But now I want it to be either that it's enough that it's touching the planet, or it should be welded to the planet. So like if we allow it to only touch, then you could build like a car that drives slowly around the planet, which could be pretty cool. It just drags a miner with it, kind of thing. Or it has to be welded, in which case it would be a bit more of an operation to move it around. You would have to bring out a welder, and to get it off there, you would have to have a torch module. And then there's also the option for any of these three options. We can also decide if we should let it mine these surface boulders or not. I think for the flying one, obviously it's going to be able to, or not obvious maybe, it should be able to take those boulders. But then the flying one, why, like, it could take any resource. Like, it could be taking this storage and stuff like that. But like, what's distinguishing these things? Because the boulder here just has a worth. So perhaps again, it would only be the boulders inside the planet, like these ones. So yeah, so we have 6 different options, 3 times 2. So mining from the air, from any distance, mining touching shapes, or mining touching and connected to the same body, and then being able to mine the surface boulders or not. To begin with, I'm just gonna make it so it has to be welded to the planet, and it's only gonna do the buried boulders there. Alright, we got a miner here to our right. Let's turn on God mode, since we don't have 200,000 power connected to it. And if we zoom out, we can see the circle, and the idea is it should be able to reach these boulders down there. So let's try and turn it on. Yeah, very nice. So it's, I'm just printing out the first mineable shape it gets. It seems to be a bit random actually, that's a surprise. Pretty cool. Let me show you this as well. So the range of this thing should scale with the size. Yeah, probably a bit too big right now. I don't know. Let's turn this down to like 25. And then try and get buried boulders closer to the surface. What am I doing here? push that out. Right, so let's put this like that instead. Because I used to be 1,000, but I never changed that one. Let's see what this looks like. Yeah, a bit better. Let's get a few more in there. Cool. Maybe make it twice as big. Right, that looks a bit better. I made them smaller and the range a bit bigger. And then this scales with the square root of the mass, since the mass increases exponentially. This is the way I scale the sphere of influence, by doing the square root of the mass. But that looks pretty good. So like this huge miner could do almost the whole planet. But like this is super expensive. 64,000 titanium and 21,000 silicon. So the balancing is gonna be a mission. Alright, cool. Let's actually try and make it drain the resources. Okay. Got some stuff done. So now got a basic setup for a miner spawning here, and we got a battery up top, 250k power, 64% filled, storage on the left, that's empty, and the miner itself, and this is just a pipe there. And the miner consumes 2.7k power, so that's like 1% of what we have there, and there's a built-in cooldown for 1 second on the miner, and let's try and turn it on. So you can see we're slowly gathering up iron there, and we are draining the power. So this is the range, so we must be pulling from one of these two. And if I pause, turn on God mode, disconnect this pipe, now it's not doing anything because there's nowhere to put whatever it would mine. So it's not wasting any power if there's no room or there's nowhere to put it. It is if I turn on God mode, because then it neglects limits like that. And it would keep running even if we don't have power. On God mode, that is. But turning off God mode, letting this keep running here. Getting some silicon, iron, copper. Very cool. Want to make it so we can like look at these shapes, see what they contain. And then that would only be possible if we have a scanner. And speeding up time here, we can see when it's drained, it's gonna stop by itself. Here we go. Very cool. So then, like I imagine, we only put the miner out there in the beginning for the survival mode. And then the user will have to bring their own storage, their own power. They can like put a solar panel up here to bring in more power here. I updated some query functions we had to get shapes at a certain position. This was previously not so well implemented and it didn't have distance support, so I just joined together these and cleaned it up. So we have one where we get the queries, which is useful if we want to have the distance and such, for example for the magnet. But then otherwise, usually it's enough to just get the shapes, and now that returns a shape set. So when we use this, it's easy to optionally only get the sensors, to get no sensors, and then convert to a single shape. And this single shape method is where I implemented so it prefers the sensor. I'm sure we could come up with a better way to resolve the z-index here. But for now, I'm just prioritizing sensors. It's like if there are two shapes in the same position. Hooking that into our hover method and like click methods, we can now highlight the mineable shapes. We can actually right click them and see what they contain. It's titanium silicon there. It's mostly scrap. 10% silicon, pure titanium in that one. Oh, okay, before I forget, I've said this before, I want to write the purity here. Perhaps something like this, added another helper method for percentages, and then right below the name you can write the purity. I feel like I should rename this though. It's called cost multiplier now. Kind of belongs with the worth though. Yeah, let's put it below the worth. Put this in a single line maybe. Worth. Where is the worth? Down there. Ah, I do the whole thing. If there are multiple shapes, do we just take the average purity or a weighted average? Because we have the mass, right? Right there. So it's pretty easy actually. We can just calculate the purity. It's going to be the worth's mass over total mass. Cool. Oh, shapes. Oh, that needs to be a visible function though, a callable, so we can update it. Means we just have to recalculate it down there, I guess. Yeah. So it's gonna be a bit inefficient, but I think it's fine. We already got that there, so worth. What if we put it on the same line? Is that too much? Just write a percentage right here. This is getting long. Let's write this out. All right, something like this perhaps. Yeah, that looks better. Let's check out the boulders. Nice. Okay, not the most intuitive for like new players, but think that's good. Very good. Let's save this. What else did I do here? Right. Purity, context menu, and resize. So that's what I wanted to show you. But now that we got the purity showing, really nice. So that's what I wanted to mention. Right now, the way the miner works is that the maximum amount of resources it can take scales with its the square root of its mass times its efficiency. The efficiency is defined by like if it's a basic miner or an advanced miner. It's defined by the content. But we could also multiply this by the purity of the boulder it's mining. So if you have a 100% pure boulder, it's gonna mine much faster than one that's not, right? Like here, 37%. Yeah, so that's pretty cool. Let's quickly implement that. We just multiply this by module.worth cost multiplier. Can we just change this first? Just make sure we scale this properly. In there, we should multiply it. Shape module, and it's always going to have a module, right? Yeah, I think so. Scale mining with purity. Nice. And let's rename this bad boy. Just purity, I think. Boop. And let's run all the tests. All right, we're cooking. Really nice. Rename to purity. So, as oh, god dang it. To continue showing you what I've done. Oh, it's rolling. It stopped. Let's make sure we have a boulder in range. We don't. Unfortunate spawn. Okay, so we have a boulder here, 67% pure with only scrap. 2 million scrap in that one. Okay, cool. And so now let's try and turn on the miner. Oh, it's mining from this one. So you can see it's actually shrinking now. Ah, so cool. It's not scaled properly. Oh, now it's taking that one. It's a bit random. Or no, this one is now outside the range, the circle. Yeah. Yeah, so that's a really cool effect. Like as you mine a deposit, it's gonna shrink, and then you might not be able to finish it if you have it too small of a miner. Ah, that's nice. The purity is 100,000%. Yeah, so I'm just resizing it now without any checks. Oh, that's fun. See how we're doing up here? 140k power left. We got a bunch of scrap and copper there. Nice. Okay, so let's calculate this better. When creating any shape in the game, I calculate the density of the shape based on its area. And the idea is that they should have their mass grow exponentially as the area increases. And to achieve that, I thought I'll assume that the area is a projected sphere. And then we convert that to a volume. And then we use that volume to calculate the mass, and when we have the mass we know what the density has to be. But like this is very complicated. This took a while to come up with, and I think yeah, AI helped me with this formula. And then but this is like a general equation, so that's cool. But now, and that's all been working very well, and I even have support to change between this setting. And actually if we put this to 0, then it's gonna treat them as they're flat circles, so then the mass increases linearly with the area. And you can put this like 0.5 to put it somewhere in between. But I think I'm gonna get rid of this and always make it 1 for sphere, because it becomes a bit too complicated. So yeah, because now the issue is that I need to go the other direction. Because now when we mine a boulder inside the planet, we're gonna have a mass, and the question is how much area should this shape now have based on the mass, because I want it to be stateless. So when we create the boulder, we just create the random shape, and then the mass is calculated based on the area, just like usual, and then we create those resources based on the purity, based on the mass. But now as we remove resources, we're gonna have a new mass. So I was thinking we should be able to calculate any of these units. We have volume, area, density, and mass. And I've been fighting with this for an hour, and half of that time has been spent when I gave up trying to do it myself and wrestling with the AI to do it. But eventually I believe I have something working, and that's pretty nice. Also added another unit, which is radius. So the radius is just when we have the area, it can be any shape, any polygon shape where it's a circle, but we assume that it's a circle, and then we calculate the radius as such. That's how we calculated the sphere volume anyway. But this is really cool. So now we can instantiate this density class from any of these units. And then we can calculate any of the other units from that one unit. Oh my god, what? What? When did that happen? This is really nice. And I also got the magic value incorporated there so that we can control actually how heavy all the shapes are with the multiplier there. So this is cool. So we can run this and like instantiate with area 15. We get these values. And like we should get the same values if we do this instead. Yeah, I think that's right. Now to use this, I'm gonna implement it here and then in the miner as well. This is so nice. I love implementing clean code like this. So now for our volume and update density methods, all we do is call density, instantiate both of them with the area, and then here we just take the volume, and here we just take the density. Before we all had all this stuff there, before we were heavily coupled to that single function there that I've now removed. And in the miner now, call the same class, but now we instantiate it with the mass of the worth over its purity, because that's the way the resources were calculated. We multiplied by purity. And let's see if this works. All right. Any shapes inside? Yes, sir. So let's just run this. Okay. It's not density. Whatever. Anything inside? Not sure. Let's try it. Yeah, we got 2 iron, but it's not looking correct though. I might not be generating the resources actually in accordance to my usual system. Let's see. Yeah, because we randomize it here. Yeah. Okay, so it's heavily randomized, but then we need to normalize it. Or just recalculate the purity. But we set the purity there. Okay, so there's a disconnect here. Should be a pretty easy fix actually. Because we have the collection and we have the purity. So now we just multiply the collection by the actual target mass. And the target mass should be boulder mass times the purity. So that's the target mass. So if that's 5, but the collection is 2.5, then we should double the collection. So we just take this over the collection mass. I remember saying I wanted the game to support resources not having mass, like in the content. If a content creator wants all resources to not have a mass, but I'm afraid that's not gonna work. I'm assuming the resources have mass in a bunch of places now. And I'm not sure how it would work if they didn't have mass. So I'm afraid I'll enforce mass for resources. But yeah, so this should normalize it. Should probably create a method for that, but collection. Oh, shouldn't set the collection yet though. There, we set the collection. Okay, let's see. All right, it's looking good, but we don't have any boulders in the range. So let's reset. There we go. And run it? No. 46,000 and 244,000. It's the worth dot mass over area. Purity. Did I mess this up after all? With the total mass of the boulder times its purity. So if this is 10 and it's 70% pure, we're gonna have 7 kilos is what we want it to fill up. But then if this is only 3.5, we're gonna have 7 over 3.5 is 2. So then it should make it larger. Wait, I can't just multiply it. Or can I? Because resources weigh differently. But no, if I multiply each resource the same amount, it should work, right? Yeah, of course. Yeah. Wait, cost. Cost is not the... I should be setting the worth. Okay. Because I'm trying to set I'm calculating the worth here, not the cost. Because then the cost is actually used in cost calculate, and then we multiply this by the mass and purity and stuff again. Okay, so this explains it. Can I just set the worth directly? What does this function do? Yeah, because we don't need to consume mass, yada yada. Cost calculate. You just set worth. Yeah, okay. But is this instantiated? Okay, so we set the module there. So we remove the cost there. We don't need to consume the worth, but we set the worth directly as the collection. Let's just rename this to worth so we know what we're working with. Okay, let's see. Any shapes? Oh yeah. Do it once? No. Oh my god. I tried calculating it right after we create the boulders and it all checks out. But now I found the issue. We're calculating it after resizing because I'm halving the shape just to test the resizing. So, of course, the shapes area is going to be different. So now, just comment that out. Ooh, frustrating bug. Let's see. Yes, they're the same. All right. So now, or like they vary just a tiny bit because we took 9 scrap. So like 9 scrap from yeah, like 216 tons, 1 million tons, off a million ton. It's a very tiny amount. So the idea is we don't resize it every single time. We just resize it when it's changed enough. And now that we can have it stateless, like I said, it should work perfectly. So we just compare the actual area of the shape to what the area should be with this current mass. But then area scales with the square. So we're gonna have to do the square root, I think. Let's see. When we resize on the corner. So if I half that, then the area goes a quarter the size. So we should just go area over shape.area because this one's going to be smaller and then that's our target area. So then if we resize with this, we're going to resize way too much. So it has to be square root of this. And that's all we do like that. And then we can check here if it's like less than, if it's bigger than 1% change, then we can do it. Cool. Let's print this out for good measure, just now that we're testing it. And yeah, it's never gonna resize now because this one is tiny, but we should see it go down there. Yeah, nice. So now let's just make it mine a lot more. And the easiest way to do that is probably just multiplying this max amount by 1,000 maybe. Why does it? Oh, we filled up. Yeah, it filled up right away. What if I turn on God mode? No, doesn't matter. How do I test this? Like, I think it's working, but what if we turn off the distribution? No, but that means it has to remove from the worth. So what if we increase the storage capacity of the storage? For now, it's gonna be in structures. And how do I do that? Action volume max. There, storage volume multiplier on the module. Okay, so we go storage dot module. Nice, 110 million liters. That looks better. Turn this on. Oh, no, it's working, but it's not printing anymore. Did I turn off the printer? Whoa, yeah, something's wrong. Okay, but this might be because it got empty. We're so close. I can feel it. Let's just no. Okay, so it's trying to take more than is available. But why? Oh, yes, right. Because I multiplied by 1,000. I should have multiplied it there. Okay, so that should fix that issue. Oh no, the max amount has to be multiplied too. Wait, no, what the? Oh, this is all wrong. The max amount should be multiplied by the purity. And the max we can actually take is the amount that's in there, left alone. We can't multiply that. And then we have the max amount up there, which is the mass and the efficiency. And it can't be lower than 1. Okay. Jesus. Oh, and this is a float now, since we're multiplying there. Let's just round here, maybe. I feel like it's not taking enough. This percentage is a bit bigger, so let's add another 0 to this one. Remove that one. Alright, check it out. So let's turn on the miner. You can see shapes starting to disappear, shrinking down. Only 2 titanium and some scrap left. 15 scrap, and gone. So now it's actually even deleted when it becomes empty. Comes the next one. Nice. Let's see which one it's gonna pick next. This one. Zoom in. 2 tons, 1 ton, 100 kilos, 30 kilos, and gone. Nice. Alright. Really cool. Yeah, seems to be working great. Just keeps on going here. Very nice. And it's out of power. Let's see if we add a solar panel to this. If we can charge up the battery. Oh, it's spreading the power to both of these. The storage can hold power as well. Let's see if we can finish up. Oh, it's already finished. Alright. But this is really nice. So now we can try and incorporate the miner into the survival mode and actually make it part of the gameplay. I updated the code for when we spawn boulders that are mineable, and now it looks like this. I made the radius scale a bit with the depth, and then I also prevent them from spawning on top of each other like this. And also make sure they're not sticking outside. Pretty cool. And then I shoved the miner over here to the right, and it spawns just by itself. Maybe it's a bit far. But yeah, I think that's pretty cool. And I reduced the amount of... Whoa, that was a 100% pure one. Never seen that. I reduced the amount of different resources a boulder can have down to 2. Used to be 3. Felt a bit convoluted. And I like the scale we go here now. Like we have the surface boulders kind of in this size. This is the biggest kind of. And then their biggest size is the smallest size of the buried ones kind of. So it's getting time for some more playtesting. But that's gonna be it for this episode. So thank you for watching.